Hi, and welcome to a video about the, structs or structures in C. You can see I'm in the cyber closet for this one. And I thought I'd talk a little bit about why structs are important, how to create them in C, the standard way of setting them up with hash include files, .h files. And then in this next video, we will actually walk through an example of coding a struct and implementing it. And you can see this is basically exactly what you'll be doing in Project 7. Let's talk about, first of all, where does the word struct come from? It's actually short for structure because it's an aggregation, a group of data. It has a structure with a name and members. Probably it's called struct, at least my theory, because everything in C has to be abbreviated. These are the folks who designed C, and they didn't want to type out integers, so they typed int and so forth and so on. So I guess when it came to structures, they thought we'll just type struct. struct. So there we go. Structure are important for the same reason that databases are important. They allow you to group together related attributes or characteristics of some entity. Now, an entity is anything you want to collect information about. In Project 7, you'll be able to choose the topic or entity that you make your structs about. The example I'll go through in a few minutes uses phones, mobile phones, cell phones, as an example, but you could do dogs or cats or sports teams or anything that has that exists and that you can think of several attributes or characteristics that describe it. Those things go into a struct. Structs in C are also important because they're the keys to classes and objects. Classes and objects become very important in every programming language because they allow the construction of reusable code. And they provide an organization for your code that is probably better than just having a lot of functions and no collection. So a struct in C is as close as you get to an object in a coding sense. It's not quite an object. It's not quite a class. It's very similar to a class in C++, and you'll see that. When and if you study C++, you'll find that in C++, structs and classes are just like this. They're almost exactly the same thing. So we're on our way, when we look at structs in C, to thinking about objects and classes. Also, structs are necessary in a number of contexts, but one particular one that may be of interest to you is when you're constructing dynamic data structures, such as linked lists. A linked list is a singly linked list, is a group of nodes, each node is a struct, that are chained together using pointers, so the list can grow and shrink as necessary. And that's exactly the sort of task you'll be given very early on in your CS1 classes at UCF. And so you need to know at least a little bit about structs to be able to make that first linked list assignment. So let's think of a struct as a template. The struct definition itself has no data. It just says, here's what goes in this struct. And you'll see in a separate step, we actually put the data in it. So in that sense, it's like a template. Here's an example. This is like a really geeky example. I apologize for that, but this is the kind of stuff I'm interested in. Suppose you had a struct that described various microcontrollers. Now, you might have heard of the Arduino microcontrollers or the Raspberry Pi. So I have several of each and some others too. I want to track those. I want to keep track of their characteristics. So let's say almost like a database, but in C. So to do that, I've come up with this schema or this template or this, what will be a struct. I collect the name of the microprocessor, that's like Arduino or Raspberry Pi. The manufacturer, that's the company who made it, and usually the company that made the chip. The model for Arduino is a common one is an Uno or a Nano. For instance, the number of GPIO, general purpose IO pins, basically how many things you can connect to the microcontroller because they're really good for controlling, lighting up LEDs, turning motors on and off, sensing things. Those all require that you connect to pins. And of course, there's the amount of RAM they have. They have surprisingly little RAM in some cases, as you'll see. So those are the attributes. Those are the characteristics of a microcontroller, the ones I'm tracking. There are lots of others. As you can see, this looks an awfully lot like a database. This looks like the schema for a database. If you imagine name, MFR, manufacturer, model, GPIO pins, and RAM as being column names, the types below, a name has to be character, a manufacturer has to be a character, model, because they have letters and numbers. The number of pins is an integer inherently, and the RAM is a floating point number, which allows us to have really big amounts of RAM or really small amounts of RAM, fractional gigabytes. Those things together would actually let you define a database table in most database packages. But instead of doing that, we're going to define it in C. Now here's an instance of that template. Okay, so that was the struct before, but it was empty. There was no data in it. Here's an example of putting data into that structure. You give values to the members. The name, the manufacturer, the model, those are called members. Pieces of a struct are called members. Pieces of an array are called elements. It helps if you keep that terminology straight in your head. The name might be Arduino. The manufacturer is Atmel. You might not have heard of them, but that's a large semiconductor foundry who makes the actual chips. The model is an Uno, because that was the very first model that Arduino came out with. It has roughly 14 available pins for you to connect to, and it has a whopping 0.002 gigabytes of RAM. That is actually 2 kbytes if you get your calculator out and figure it out. Very small amount of RAM because it's a very small chip intended for specific purposes. So that's an instance of the struct. Here's another one. I filled it in this time. You might imagine this as another row in the table almost. For the Raspberry Pi, the name is Raspberry Pi. The chip was made by a company called Broadcom in the UK. The model, they're up to the Pi 4 now. They had a Pi 2, Pi A, Pi B. They're up to Pi 4. That's the latest and greatest. It has 26 pins that are available for connecting to things, and it has 4 gigabytes of RAM, almost up into the very low-end laptop class, which means you can run a Linux operating system on it and do lots of things. So here's what that template or struct definition looks like in C, and it's actually called a type def. Type def means you get to define your own type and use it in your programs. Now, the existing types are like ints, floats, chars, char stars, so on, the ones that are built into C. Here, when you use a type def, you define your own type, which you can then use in your code just as you would use an int. But in this case, instead of having a single value, a scalar value, your struct has all of these members. And every time you refer to it, you get all of this stuff. So it has a name. I made an array of 50 characters, so there'll be lots of room for a long name. The manufacturer, I made that 50 characters. The model, I made it 50 characters. I made an int, or an integer, for the number of GPIOs, pins in other words, and I made a float for the RAM. This is what it looks like. The one thing, there's a typo on the slide. The one thing it's missing is right at the very end here, it should say microcontroller. So, but we'll see that in the code example. I fixed that, so you'll see that. So here's what it would look like to put data into those structs. If you look at the top line, 2 examples, one for the Arduino and one for the Pi. If you look at the top line where it says microcontroller my Arduino, microcontroller is the type def. That's the struct that has all those members we saw. My Arduino is the name of this particular struct. I could have named it Fred, but that's kind of a dumb name. Microcontroller the Pi is another example. I called it the Pi because I could have called it my Pi or my favorite microcontroller or X, although it helps if you have meaningful names. What's important is I said to the C compiler that it's a microcontroller struct. So now the C compiler knows, okay, it has all these members that I can manipulate. To put data into the members, to put data into the character members, as you might imagine, you can use strcpy, which comes from string.h when you hash include string.h. And notice the notation here. It's the name of the instance of the struct, the variable, with a dot, that's a dot operator, followed by the member name. So put the word Arduino, missing a quote in my example, into this member of the struct. Put the name Raspberry Pi into this member of the Pi struct. Put the model Uno into the model member of the MyArduino instance, and put Pi 4 in the model for the Pi. Watch these slides. There's lots of typos. Anytime you type code and don't compile it, lots of typos creep in. So don't take these too literally. They're basically correct. We'll look at, I see another typo. We'll look at a code example that actually compiles, and then we'll know it's syntactically correct. When you want to assign to, those were the strings, those things needed stir copy to work. When you want to just assign to a numerical variable, all you need to do is assign. So myarduino.gpios gets 14. The pi.gpio gets 26. The RAM in the Arduino gets 0.002, that's a 2K. And the Pi RAM gets 2.0 for 2 gigs. That's an example of instantiating, which is a term from object-oriented programming, creating a variable that is of type microcontroller, and then filling in the members in 2 different ways. If you want to print the struct out, this is something I'll ask you to write this function as part of Project 7. You can do it with a printf, of course. And assuming that my struct was named MPU, which I haven't declared in this example, but I'll show you that in the code, I can print the name, the manufacturer, and the model. Those are all %s's. I can print the GPIOs with a %d, it's an integer. And I can print the RAM with as a float. So there's nothing magical about printing these, except that you need to have name.membername. Struct name.membername, struct name.membername. The syntax is a little bit different, but everything else works the way that you're used to with simple scalar values that only have no members. Now, here's an example of a struct, yet another possible value for a microcontroller. And we'll just skip quickly past this one, but keep this in mind. Now I have one microcontroller struct, but I'm going to have 1, 2, 3 variables or instances of that structure to use in my program. If I look at all of this together, does it remind you of anything? Maybe it reminds you, particularly if you had a class in database already, it might remind you of a database. That's pretty much exactly what it looks like. This looks like a column name. This looks like a row. This looks like a row. This is a row. Now, this isn't actually a database. This is actually looking at what an array of structs. Yes, you can put structs in an array, and you're going to want to do that if you have more than one of them, because manipulating them one at a time is a lot of tedious typing. If you put them in an array, then you have a way to, using loops, go through and do something to like a whole bunch of structs. And if you track a lot of data, like you try to track every kind of microcontroller ever made, you would end up having a big array of structs, right? They all have the same members that you see across here, but there'd be row after row after row, meaning there'd be variable after variable after variable of type microcontroller. So this is kind of a view of logically what the data looks like. What it looks like when you code it in C is this. So microcontroller, remember, is the struct. That's the type def. That's the kind of struct we're using. My micros is the name. And the bracket 3 bracket just says, as in every array you've seen so far, the maximum extent, the number of possible elements for this array is 3, the number in the brackets. And if I assign, this is an interesting assignment. Think about this. My micros at subscript 0 gets my Arduino. That means that everything in this struct, the MyArduino struct, gets copied into this element of the array. And everything in all the members in the Pi struct get copied into this one. And all the members in that last one we glossed over, the ESP32, gets copied in here. So now I have that exactly what you saw in the table up here. Subscripts down the left-hand side, and then the members to make actually an array of structs. And then, of course, I just printed out a little bit of it to show you how you would print it. which is you would give a subscript, the name of the variable, the name of the instance, a subscript, and then the member that you want. So the projects that are coming up, they're going to use structs. I'll kind of quickly overview those. There's information in Canvas about this, of course, but projects 7, 8, and 9, they go in a sequence, they all go together, and they all build on one another with these basic ideas about structs. First, let's look at project 7, because that's the starting place. You pick a topic, an entity about which you want to make a struct. I have suggested some. I think there's a list in Canvas: cars, phones, pets, recording artists, so forth and so on. But you can pick your own. I mean, if you want, you could do Instagram influencers if you like. I'd be kind of lost in that one, but the struct would make sense to me. You post a claim for the topic you want to choose. So let's say you choose phones, because we're going to go into a phone example later on. Actually, you can't choose phone because that's the example I'm going to give you, but you'll see. Imagine that you chose phone, and you post a claim in the Project 7 discussion forum saying, I'm doing phones. Okay. Then you design your struct. This is the part we have to think, by identifying the important attributes, characteristics of your subject. Which things are important about a phone? What kind of information do I need to track about a phone? What probably comes to mind is the brand. Is it an iPhone or Android? Android is actually like a whole family. So is it like an iPhone or a Samsung? How much memory, how much storage does it have? How many megapixels does the camera have? What color is it? You could probably think of a whole lot of attributes. You don't need more than about 5 or 6 for this topic. So you design that. You can do that on pencil and paper if you want. Then you code your struct definition. Okay, so now you convert your idea about what you want to track, the attributes or members of your struct, into code. So you define that type def struct, and you create members of the appropriate type for each thing you want to store. Probably the phone's model is a character array, probably the amount of storage is a float, and so forth. You code that, and please put comments in it saying what you think each member means, because as you probably saw from my example, it isn't super obvious just reading the names of a member in a struct, but what it means, right? What does GPIO mean? Well, I should have spelled out or explained, or in a comment put GPIO is the pins you use to connect, something like that. Easy to do, right alongside your struct, so the documentation goes with your code. So you code it up and you save it in a .h file. This needs to be in its own header file. Sidebot goes through some of this, although it's a bit confusing. But the convention is, instead of putting everything in one .c file, put your struct definition, your type def, in its own file, end it in .h, and hash include it into your C code when you use it. And then you post the contents of your .h file. So you can do a screenshot of it, and you also attach the .h file to your discussion post. So what's going to happen is someone else is going to choose your .h file to implement in their C program, and it will be a lot more convenient for them to be able to look at the discussion post and see what you're doing. And then if they want to do that one, they claim it, and they can just download your .h file and start using it without having to retype it or copy and paste it from a Canvas discussion post, which often does not work correctly. So those are the basic steps. That's just to get started. You're going to end up, I'll show you the code in the next video with what you're going to end up with. So let's code an example together in the next video.